Hello, today we will learn about refraction through the rectangular glass slab. The aim of the activity is tracing the path of a ray of light passing through rectangular glass slab for different angles of incidence. Measure the angle of incidence, angle of refraction, angle of emergence and interpret the result. And then we will draw this observation table and we can find out the values. The materials required are protector, scale, pins, pencil, eraser. This is drawing board, paper and rectangular glass slab. Fix the A4 size paper to the drawing board by using the 4 pins as shown in the figure. Now place the rectangular glass slab on the A4 size paper and take the outline of the rectangular glass slab. Mark the points A, B, C, D. Now to the surface AB at a point O, draw the normal by using the protector like this. Keep the protector like this and take the 90-degree. And with the help of a dotted line, draw the perpendicular line to the point O and mark it as a N dash. Now place this protector on the point O 90-degree like this, and from the normal take the angle 30-degree, that is consider this 90 as a 0. Now from here 10, 20, 30 and draw the incident ray. This is the incident ray and this is the angle of refraction. Sorry, not angle of refraction, it is the angle of incidence. Now mark P and Q, 2 points on the incident ray such that they should be far away from 5 to 6 centimeter. Fix the pin at a P, another pin and fix it on a point Q. Now this is the incident ray. Okay, now keep the glass slab like this. Okay, now we have to observe these 2 pins from the other surface of the rectangular glass slab, that is C and D, and we have to fix the 2 pins in such a way that these 2 pins these 2 pins should come in a same straight line. Now you can see in the this video that these 2 pins is the incident ray. They are in the same straight line, and from this end CD, if you see that these 2 are in a straight line. Now take the 2 pins and we have to fix in such a way that these 4 pins should come in the same straight line. Now you can see that I have fixed these 2 pins, and these 2 pins and these 2 pins appears that they are all lies in the same straight line. You can see here, but actually they are not in the same line. This is incident ray and this is the emergent ray. Okay, now you have to remove the pins and we have to join these 2 points. So after removing the pins, we can mark these 2 points as R and S and join these 2 R and S with a scale and produce it backward in such a way that they can touch the surface CD. Now where this ray is called emergent ray, okay, and draw the arrow mark direction of the emergent ray. Now where this emergent ray touches the surface CD, at that point you mark it that point as an O dash. Now from this point O dash we will draw the perpendicular to the surface CD. Mark this 90-degree and with a scale join these 2 points with a dotted line and mark it as M dash, and this M dash is the normal to the surface CD, and this n dash is the normal to the surface AB. Now you have to join these two O and O dash. O and O dash. After joining, now this angle is called angle of refraction. So we can dot it as R1, and this is I1, angle of incidence at the surface AB. Now this angle we have to measure it, and before measuring that one, we will make this angle. This is called angle of emergent. Okay, and this we can see is I1, R1, and this is I2, and this is R2. Now we will measure this angle, and I will show how to measure this. Now we will mark like this. One more time you can check it. This is the incident ray, and this is the normal. The angle between the normal and incident ray is, this is the angle of incidence I1, and this is 30 degree. Now this is the angle of refraction, that is inside the glass slab ABCD, and this measures 20 degree. And you can see this one, this is the angle 20 degree. Keep like this. This protector, keep it on the normal like this, and measure the angle. You can see this is a 20 degree, and this is the angle of refraction. Now when this angle of this refracted ray, when hits the surface CD, now it becomes the incident ray for the surface CD. Now you can measure this angle. This is the normal, and from the normal you can see this angle is also 20. So here R1 is equal to I2. Why? Because this normal n dash and m dash, they are parallel to each other, and here O dash act like a transversal. Due to that, this R1 and I2 are the alternate angle. Therefore these two angles are equal. Now I will show you what this is the angle of emergence. What is the angle of emergence? To measure this one, keep this protector on the normal at a point O, and you can measure it. You can see now this is the 30 degree. Now this is the emergent ray. Now we have to produce this incident ray forward by a dotted line. This is the incident ray produced forward, and this is the original path of a incident ray. You can see this is the original path of the incident ray is parallel to the emergent ray, but it is shifted slightly towards the left side, and you can draw the perpendicular line between the original path of the incident ray and this emergent ray, and this perpendicular distance is called lateral displacement. That means the original path of the incident ray is this one, but because of the glass slab it has shifted, and this shift is called lateral shift or lateral displacement. And in this activity you will come to know that angle of incidence is always equal to angle of emergence, and the perpendicular distance between the original path of the incident ray and the emergent ray, these two which are parallel to each other, this perpendicular distance is called lateral displacement. In this activity, you will come to know that lateral displacement is directly proportional to three factors. One is angle of incidence. So as you increase the angle of incidence, the lateral shift will be more. And thickness of the glass slab. More the thickness of the glass slab, lateral displacement will be more. And the refractive index of the glass slab. As refractive index of the glass slab increases, then the lateral shift will also increases. Thank you.